This video is section 4.6, which is on arithmetic sequences. For your learning targets, you'll be able to write the terms of an arithmetic sequence, you will be able to graph an arithmetic sequence, and you will be able to write an arithmetic sequence as a function. So an arithmetic sequence is a list or pattern of numbers. And so here we have a sequence. This is a list of numbers, and each number in the sequence is called a term, and each term has a position. So this 5 is a term in the sequence, and it's the first term. This 10 is a term in the sequence, and it's the second term, and so on. And so this is just a pattern of numbers, or a list of numbers. An arithmetic sequence specifically refers to a pattern where you're adding or subtracting the same amount. So in this sequence, the pattern is that we're adding 5. And that 5 that we're adding each time is called the common difference, because that's the difference between each term or each number in our sequence. Example 1 is extending an arithmetic sequence. And so it says to write the next 3 terms of the arithmetic sequence. And we're given -2, 6, 14, and 22. So if you look, to get to -2 to 6, we add 8. To get from 6 to 14, we add 8. And then to get from 14 to 22, we add 8. So each time we're adding 8. So that means we're going to do 22 plus 8 to get our next term, which is 30. Then we're going to do 30 plus 8 to get our next term, which will be 38. And then finally, we're going to do 38 plus 8 to get our final third term, which is 46. And then when we write these, we're going to list them out. So 30, 38, and 46. So these are the next 3 terms of the arithmetic sequence. Example 2 is graphing an arithmetic sequence. And so it gives us the sequence 24, 18, 12, and 6. So we want to graph these and then see what we notice. So to graph these, we're going to make like an XY table. And so your X's are the position, like the term position number. So we have my first term is a value of 24. So my first point here is 124. The second term in my sequence is 18. The third term in my sequence is 12. And the fourth term in my sequence is 6. So now we're going to plot these points on this coordinate plane. So for our first point, we have 124. So here's 1, and then I'm going to count these by 4. So 4, 8, 12, 16, 20, 24. So here's our first point. The next point, we have 2 18. So again, this was 4, 8, 12, 16. So 18 is going to be right around here. The next one, we have 3, 12. And the last one is 4, 6. So when we're graphing a sequence, we do not connect the points. So you're just going to leave the points as they are. We're not going to connect them. Because in a sequence, we don't have a number, an X value, that's between this 1 and this 2. It's either the first term or the second term. We don't have like a term and a half. We don't have a number in our sequence in between 24 and 18. So that's why we have to leave these as just dots, just points. So then it's asking us what we notice. Well, hopefully you notice that this follows kind of like a linear pattern. Okay, so your arithmetic sequences, when you graph them, they follow a linear pattern. And look like you're graphing a line. So example 3 is identifying an arithmetic sequence from a graph. And we're asked, does the graph represent an arithmetic sequence? Explain. So I want to copy down these points into an XY table. So we have 1, 1.5, 2, 3, 3, 4.5, and 4, 6. So what we're looking for is to see if we're adding the same amount each time to get to the next number. So 1.5 plus 1.5 gives us 3. 3 plus 1.5 gives us 4.5. And then finally 4.5 plus 1.5 gives us 6. So yes, this is an arithmetic sequence because we have to explain the common difference. So remember, the number that you're adding each time is called a common difference. Is 1.5 each time. So because each time you have that common difference of 1.5, then it's an arithmetic sequence. Okay, so this slide is basically to give you the formula for an arithmetic sequence, which is all the way down here at the bottom. So this a sub n equals a sub 1 plus n minus 1 times d. So a sub n is referring to any term in your sequence. Can be found by doing the first term a sub 1 plus the quantity n minus 1. So whatever that term position is minus 1 times the common difference. So this is kind of the formula to set it up, and then we do end up simplifying what's here on the right. So example 4 is finding the nth term of an arithmetic sequence. So it says write the equation for the nth term and then find the 30th term. A sub 30 refers to the 30th term. So there's going to be two separate answers to this problem. One is the nth term equation, and then one is the 30th term. So I'm going to write down that nth term equation that we saw in the last slide. So a sub n equals a sub 1 plus n minus 1 times d. So a sub n is going to stay. A sub n. A sub 1 is referring to this first term in your sequence, which is 7. N minus 1 is also going to stay. And then d is referring to the common difference. What am I adding or subtracting each time to generate the next number? And you should see that you're subtracting 4 each time. So that means my common difference is negative 4. So even though this is written kind of like a little bit backwards, we're still going to be distributing this negative 4. So I'm going to bring down my a sub n. I'm going to bring down my 7. Negative 4 times n gives you negative 4n. Negative 4 times negative 1 is positive 4. So 7 and 4 are on the same side of the equal sign. So we just need to combine like terms. So I brought down my a sub n and my equal sign, and then I'm going to rewrite my negative 4n first, and then combine my like terms of 7 and 4. So 7 plus 4 is 11. So this is my nth term equation for this sequence. So now the next part of the problem wants us to find a sub 30. So I'm going to take this same equation and I'm replacing my n with 30. So I have a sub 30 equals negative 4 times 30 plus 11. So this a sub 30 over here, this is still just like a parameter. It's not moving anywhere. This 30 isn't going to do anything, go anywhere. It's going to stay right here. So we're just simplifying this right side. So I'm going to bring down that a sub 30. Negative 4 times 30 gives us negative 120. And then I bring down that plus 11. And then I'm going to combine those like terms. So I have a sub 30 equals negative 120 plus 11 is negative 109. So this is my second answer. So what this means is that if I were to continue this pattern, if I was going to continue to subtract 4 each time until I got to the 30th term, the 30th term in this list would be negative 109.